We're going to start with a parallel. Well, no, let's do this a little different than I did first hour. Let's start with just a straight up rectangle, all right? I'm going to try to draw a perfect one. Oh, I'm so good at it. Okay. And so to be a rectangle, opposite sides are parallel, congruent, and I get right angles, right? That's what makes this a rectangle. Okay? And let's just say this rectangle is 8 by 3 centimeters. And from your Decimals activity, you had a grid, right? Something like this. And to get all the boxes in your grid, you did 8 times 3. And that's the equation. Base times height. So a lot of people are going to want to skip right to the answer, and here's the issue with that with me. Eventually, we're going to have like all these volume equations, maybe some surface area equations, some composite area stuff. This is the first place I can check to see if you're on the right track, right? Did you use the right area equation? If you don't have this, if you just wrote 24, let's say you just wrote 28 and it was wrong. How much do I know?
No.
I know nothing, guys. So this is just like a little intermediate step. I know, remember that first hour kid? He was sweating pretty hard from writing it all again. But also, what do you notice about our units? For area. Square, right? Because it's 2 dimensions. There's a length and a width. All right? So I think the harder jump for a lot of students is when we look at a parallelogram. But a parallelogram is no different. So a parallelogram might look something like this. It's like the slanty one, right? Okay? Now, here's the thing you're going to see on your homework, and you probably already saw a little bit, is you'll see these little dashed lines. And these little dashed lines are, it's not part of the figure. It's showing you part of a measurement, okay? Because the area of a parallelogram, we need a height. And the height needs to be consistent. This right here, not the height. All right? That's not the height. The height is the distance between the 2 bases, which would require a perpendicular line between the 2. So that's what this line is. That's saying the height, or the distance between 2 bases, is 4. Does that make sense, that little dash line? It's a reference point. It's not part of the figure. But you need it, because again, this right here, that's not the height, that slanty line. And in fact, we haven't done a lesson yet where you could even calculate that slanty line yet. But this is the same equation. The base would be 6, and the height would be 4. Remember, the height's perpendicular, one base to the other. You might also see that happen right there. You might see a 4 right there, depending on the figure too. It goes perpendicular base to base. Cool? So in this, the area would be 24 square inches. Now, one other thing I like to show you that's kind of cool is, imagine we cut this off right here. See that triangle? And look at, if you were to slap it right there, what shape do you have? Or a rectangle, probably. But yeah, which is just the base times height. I'm just proving another way why that works, right? Do you see why that would work? If you cut off that side, put it on the other side, you just have yourself a rectangle. It's kind of cool. I like imagining the stuff moving around, too, in my head. So that is the parallelogram rectangle, base times height. Now, let's say we have that rectangle, okay? And let's say this rectangle, let's get crazy. 12 miles by 2 miles. It's a huge rectangle. Okay? No, it's not to scale. Let's just say that. Now, let's say though these people are going to cut. This is property. They're going to cut it in half and split it. What do I have there? I have 2 what now?
Half.
Yeah, and if I want to know my half, that's a triangle. And that triangle you just told me is half of the rectangle. So you'll see that as 1/2. This is how I like to think of it, half of the base times height. You'll also see it as base times height divided by 2. Those are the same thing, okay? So if I were to show my work for this, if I want just this triangle, okay, I would write area is half of the base times height because it's half of the rectangle. Same base and height as the rectangle, by the way. Half of 12 times 2, which is 12 square miles. That's a good chunk of land. 12 square miles. Yeah, you should write that down. But again, the big idea here, you know how I like to focus on big ideas, is a triangle is how much of the rectangle? Half. It's not a new equation to memorize. It's just a new thing to understand. And then the equations, you've got it. It's ready to pull out of that head. All right? Now I want to show you one more type of triangle. Notice this has a right angle here, right? Yeah. Okay. I had some kids earlier get a little tripped up about like a triangle that looks maybe like, now I'm going to get even crazier. Like this. Okay? And we know that it's half of the rectangle. Now what's a little tricky is to know what the base and height are. What do you think kids usually try to think the base is? John?
There's like one edge.
Yeah, so yeah, it is just one edge, but a lot of times students will think base is bottom, right? But in like on your paper or a triangle in space, does there necessarily have to be a bottom? No. No, like it's the same triangle no matter how you flip it. So you could be given something like this.
Why would they?
And if it was like this would be your base and this would be your height.
Does it have to be like that?
Well, I'm just saying it's going to depend what information you're given. If you're given this information, that's your base and that's your height. So you have to look for that perpendicular line again, because the base and height are perpendicular to each other.
Mm-hmm.
So I'm actually going to give you, let's do it like this. Okay, and this height is 6 and our base is 12. I'm liking 6s and 12s. And let's go meters this time. So for this triangle, this would be my base and this would be my height. It's dictated by the perpendicular line from a vertex to the base. So my base would be 12 and my height would be 6. And this is important because you could get too much information. You could be given like all the sides and you would have to know which one's your height and which one's your base because it matters. So your base and height have to be perpendicular to each other. All right, so this would give me 36 square meters. I think the computation stuff's easy. Where it gets a little tricky again is, no matter how I turn this triangle around, does it change the area of the triangle?
No.
So base doesn't mean bottom. Keep that in mind as we move into volume and stuff too, all right? Now we're moving on to my favorite one.
Oh, God. Yes, sir.
And that's a trapezoid. So a trapezoid has exactly one pair of parallel lines. Okay? If it has more than that, it's not a trapezoid. And let's just give this trapezoid some values. What units do you want, Mikey?
You know what I want? Hairs long.
Hairs? Well, that's not like a. Give me like a unit.
What I want. Kilometers.
Okay, give me one that's like a measurement.
Coffee cups long.
Cups doesn't work. That's volume.
Sugar grams long.
Okay, we're gonna go with millimeters. Thanks, Mikey. Okay. So here's my trapezoid. It's 4 sides, right? 1, 2, 3, 4. And let me show you how I like to think of it. So do this visual with me. What would I get if I extend this half the way that direction and then remove half this direction? So I'm going to extend the top or the one base that way. I'm going to make the other one shorter by the same amount. What do I get, Connor? Or a rectangle, right? Are you guys seeing that? If I make one a little longer and the other one exactly that much shorter, the same lengths, it makes it into a rectangle. And so we can make our equation do this. Check this out. So that's a subscript 1 and a subscript 2 because the trapezoid has 2 bases. And here's what my equation says so far. It's averaging my 2 bases. If I average my 2 bases, it would make my short one a little longer and my long one that much shorter, right? You guys understand adding together, dividing by 2? So I've got these 2 bases, 4 and 14, right?
Yeah.
The math right here, by adding together the bases and dividing by 2, would make them both the same length.
I would do mine totally differently.
Well, no, just stay with me. Do you understand that it would make them both the same length? If I add them together and divide by 2, I'm finding the average of those two, and that is making them the same length. Let's put numbers with it, maybe. I've got a base of 4 and a base of 14. Right? Which would say, if I made them equal sides, they would both be 9. Because I made the short one 5 longer and the long one 5 shorter is what that's doing. Which would make this into a rectangle with a height of 6. So it's kind of like using math and numbers to make a figure do what you want it to do.
See, can you also just do it by like extending the dotted line all the way over going down, and then you know that top is 4, so cut that off, you know that's going to be 10. And then just like separating it and then do that.
I'm having a hard time following you, but maybe.
Here you go. So,
I think we should
But-
just listen to the teacher.
Again, here's how I have it memorized. I know if I average my two bases, they'll become the same length, and then I have a rectangle, base times height. Really what this is base times height of a rectangle. I'm just making my numbers do it. Right? If I average, this one gets this much longer, this one gets this much shorter. I have a rectangle. I made my numbers make me a rectangle, base times height, which would give me 9 times 6, or 54 square millimeters. So I'd like to look at another trapezoid with you. And this one, I'm going to make this one look a little funky on purpose. Because remember, we can twist them any way we want, right?
Yeah.
Again, for height, I need a perpendicular line. So there's my perpendicular line. 10 inches. All right, and let's do an 8-inch and an 18-inch. Okay.
It's like you're ordering sandwiches.
Yeah.
Can I get an 8-inch or foot long?
So remember my equation, what I'm trying to do is, I'm trying to average out my bases to get me a rectangle to multiply then by the height. Averaging my bases. It doesn't matter which one you call base 1, base 2. So like kind of the visual for what I'm trying to do here is make this side a little longer, make this side a little shorter, and make it into a rectangle here. That's what I'm trying to get my math to do.
that's what I was, yeah.
So, if I add my base, I got an 8 and an 18 for my bases, and a 10 for my height. So it doesn't matter, you can use the commutative properties, right? So I've got a 26 and a 10. 26 times 10 is kind of nice, 260 divided by 2.
Oh, that's easy.
Or I could do half of 26 is 13 times 10 is 130, however you want to go about it. But again, this is giving me, this is what's turning it into a rectangle for me. It's taking my two different bases and making them the same length. That's how I like to think about it, and that's how I have it memorized.